Hello and a very warm welcome to this Lunch and Learn webinar. My name is Richard Kirk. I'm the Regional Director for ICE in Northern Ireland. I'm based in Belfast, and today it's my pleasure to host this webinar. We can see from the numbers that have logged online, with almost 100 signed in so far, and hopefully more will join us over the next few minutes, that this is a topic of real interest. And it's not just here in the UK and in Ireland, but from further afield. We can see that by those who have registered for today's event. So we're delighted that you've joined with us. Before I hand over to our presenter, John Cole, I'm going to introduce Richard Fitzpatrick, who represents Lean Construction Ireland. And during today's webinar, it really is deemed to be interactive. John will make a presentation, but as John speaks, please use the Q&A function on the right-hand side of your panel, and that'll give you the opportunity to ask questions, and we can pick those up at the end in the Q&A session. So without further ado, I'll hand over to Richard Fitzpatrick, who will be able to introduce John Cole.
Thank you very much, Richard, and thank you everyone for joining us this afternoon. I'm Richard Fitzpatrick. I'm Chair of Lean Construction Ireland, which is an all-Ireland independent and voluntary not-for-profit organisation whose objective is to promote the adoption of lean thinking and practices in the delivery of construction projects, which benefits all project stakeholders. And I'm delighted that we're able to co-host this webinar with the Institution of Civil Engineers of Northern Ireland. And the theme of the webinar is anyone looking after quality. It builds on two previous webinars Lean Construction Ireland had, which focused on quality in construction. One of those was given by Tom Burton on the Get It Right initiative in the UK, and he shared the thinking around that with us. And Dennis Leonard from Graham Construction, who did a webinar on the in construction. And I think this afternoon's topic looks at the findings of two independent inquiries into major build issues in Scotland. And I think that could not be more relevant given what's happened here in the schools sector here in Ireland, the closure of 3 schools in the last week due to structural defects, and 40 other schools across 9 counties subject to a structural assessment inspection. So it'd be good to hear what experience John has in those reviews and how we can maybe think about that for those at that sector. Our presenter is Professor John Cole, CBE. John is an independent consultant and acts as a strategic advisor to clients on a range of international public sector projects. One of his current roles is a board member and chair of the design committee the National Paediatric Hospital Development Board, which is responsible for the construction of the new Children's Hospital here in Dublin. He is also an independent member of the development and project boards, both major educational campus and a new sports stadium in Northern Ireland. Prior to retiring, John was Deputy Permanent Secretary in the Department of Health, Social Services and Public Safety in Northern Ireland, in addition to being Chief Estates Officer, Health Estates Investment Group. He is a serving member of the RIBA Council and acting chair for both the Continuous Professional Development and Procurement Committees at RIBA. John was previously chairman of the European Health Property Network and is a past president of the Royal Society of Ulster Architects. He was recently elected as an honorary fellow of the Royal Incorporation of Architects in Scotland. And in 2013, John was appointed Commander of the British Empire for his contribution to development of health infrastructure, and in 2014 was made an honorary professor in the School of Planning, Architecture and Civil Engineering, Queen's University in Belfast. So thank you, John, for making yourself available to share with us the inquiries. And I'll hand you over to you to present on is anyone watching looking after quality? John.
Thank you, Richard, for that rather flattering introduction, and good afternoon to everyone who's listening. Today, I'm going to present to you evidence of the growing concern about the lack of consistency in the quality of construction being achieved by the UK industry. My basic question is asking whether, under current models of procurement and current practices within the UK industry, is anyone taking responsibility for ensuring the quality of our buildings being produced for our clients and for society in general. My evidence will be taken primarily from 2 independent inquiries that I've chaired over the last 2 years in Scotland. Sorry, I'm just waiting for my computer screen to come on. Many of you will have heard of Vitruvius, who in the 1st century BC defined quality in architecture as requiring the three characteristics of utilitas, firmitas, et venustas, or functionality, durability, and delight. However, if what we build is not durable, users' buildings can only have limited availability of the functionality and delight that may be offered by a building. And additionally, user safety may be significantly compromised as a result of a lack of durability, which I will show in the following sections of this presentation. As an introduction, I've taken university buildings as an example of a building typology, which has over many centuries provided some excellent examples where durability was built in as a result of using the best architects, the best designers, the best materials, and the best tradesmen. The durability with which, for example, the Arci Ginnasio in Bologna was built in 1563 is still enabling users of that wonderful building, part of the oldest university in Europe, to both benefit from its functionality and to delight in its beauty. It contains wonderful spaces maintained in first-class condition, and with the walls and ceilings of the corridors festooned with the coats of arms of students of the university who over the centuries came to Bologna University from all parts of Europe. The oldest universities in England and Scotland also invested in quality and durability, placing their confidence in great architects such as Wren, Hawksmoor, Gibbs, Adam, etc., to design and oversee the creation of buildings which have become cultural icons and have helped shape Western Europe's civilization over a period of nearly 300 years. Here we see Queen's College, Oxford, designed chiefly by Wren, and here the instantly recognizable Radcliffe Camera building in Oxford by James Gibbs from the 18th century. Emmanuel College, Cambridge, also designed by Wren. And here the old College, Edinburgh, from a design by Robert Adam, still serving thousands of students and attracting sightseers from around the world. A highly valued part of the heritage and fabric of the city, and still as durable as when it was built. The slightly later library and Surgeons Museum at this university in Edinburgh are wonderful pieces of interior architecture, still bringing immense pleasure to users. And just for completeness, as we are based in Belfast today, two institutions north and south of the Irish border, Trinity College Dublin and Queen's University Belfast, provide high quality open spaces serving the communities that they sit in. Interestingly, both these were designed by the Northern Ireland architect Charles Lanyon. If we now jump closer to modern day, I'm now showing you a slide of Melville Hall at St Andrews University, designed by James Stirling, after whom the Stirling Prize was named. It was designed in the brutalist style, which was then very much in vogue. The building is important for historical, architectural, and social associations and is architecturally listed. Nevertheless, it has undergone constant repairs over the last 40 years, much of which is related to the original poor quality of the innovative form of construction used. Of course, excellent architects continue to produce inspirational university buildings, such as the Sainsbury Laboratory building at Cambridge by Stanton William Architects, which won the 2012 Stirling Prize. This maintains the tradition of patronage of design excellence by leading universities. I'm indulging myself slightly by showing more than one slide of this building, as it is a personal favourite. However, the reason I am showing these buildings is to question whether, in looking forward, we can be sure that our current buildings will share the durability achieved by our enlightened predecessors. Unfortunately, present evidence, as I'm about to show you, would suggest that the answer to that question is in the negative, and raises serious questions as to the approach taken to quality by the UK construction industry. The Grenfell Tower tragedy has brought previously largely unspoken concerns to the surface and raised questions as to the safety and reliability of buildings being produced by our industry. Over recent years, this has led to an increasing lack of confidence in build quality. The question is this the reason for this a focus on cost and time, and too few clients or contractors with a focus on quality? With fundamental changes in project and design leadership roles, who is actually charged with looking after the quality of construction and ensuring that clients get the buildings that they need. Unfortunately, frequently in the UK, this is no longer the original designers of the building. Looking back at Wren, Hawksmoor, Adam, Lanyon, and other great architects, what control would they have on site in the pursuit of quality on the average design and build public sector project today? Designers, unfortunately, appear to be increasingly relegated to conceptual design, appearance, and aesthetics, and they are losing control of the detail as actually constructed on site. It was Mies van der Rohe who said, "God is in the detail," and unfortunately, the design team seem to be getting separated from that. Increasingly, the model on the left-hand side of this, the model on the right-hand side of this diagram tends to reflect the approach now been taken, which has created a significant distance between the client and the architect, particularly during the period on site. And the role of the clerk who works as a key advisor in the eyes and ears of the design team has also been greatly reduced, so that we're relying more and more on contractors signing off their own work. And unfortunately, as is about to be shown, that is not proving to be successful. The first of the inquiries I undertook followed the collapse in January 2016 at 8 o'clock in the morning of 9 tons of brick masonry onto a playground in an Edinburgh school. An hour later, a class of nursery children would have been queuing against this wall to go into the school. The second inquiry was in relation to a major events and leisure centre in Dumfries, which had to be closed after only 6 years in operation, and recently looked like this, as opposed to what was originally built to look like, due to the fact that it had to be demolished as a result of the discovery of the same structural defects as found in the Edinburgh schools. But these problems are by no means confined to Scotland. Large national contractors were responsible for the buildings of both inquiries. This third headline reports the outcome of a survey by Shelter that suggests that more than half of new homes in England have major building faults. The Edinburgh inquiry, which reported in February 2017, recommended that risk-based assessments of all buildings of a similar vintage and construction be undertaken to determine if the same defects were present. This BBC headline from April 2017 reports that almost immediately 72 schools were found to have the same range of defects in the construction of their external walls. Currently, I believe that number significantly exceeds 100 or 150 school buildings, with regular discoveries still being reported. My inquiry report was clear that these masonry defects could not be viewed as a characteristic of only school buildings, but based on the evidence given to the inquiry, would likely be systemic within the industry. This quickly was proven to be the case, with large numbers of examples emerging in both public sectors, such as in the health sector, as shown by the headlines above, which refers to 51 health buildings in Scotland, and in private sector projects across Scotland. In addition to the widespread failures in the masonry panels discovered in the Edinburgh schools, my inquiry identified widespread failures in the application of fire stopping throughout the 17 schools. Inadequacies in the incorporation of this life safety related factor has been known about for many years within the industry, and yet has been largely ignored, leaving the basis for fire protection of building occupants in many recently completed buildings majorly compromised. Fires in school buildings are unfortunately too common. This fire in the picture here occurred just last month, but as we know, unfortunately, recently fires are not confined to one type of building. These headlines from major national newspapers over the last 2 years indicate the extent of this problem, which both sides of the industry have largely still failed to address. This headline refers to 8 schools in Manchester built in under the Private Finance Initiative. This photograph shows the remains of a block of houses in Kildare, Ireland, which in 2015 were destroyed in less than an hour due to inadequate fire compartment between the houses and the roof spaces. Major failings have also been reported in fire compartmentation in many of the new hospitals recently built, requiring millions to be spent on retrofitting to provide a safe environment for patients. Again, all of these examples were built under PFI and used design and build procurement models. And then in June 2017, this terrible tragedy occurred. It was procured using design and build. So the question again asked in our current procurement models, who, if anybody, is looking after the quality? I will now look in more detail at one of the two principal building failures identified in the Edinburgh Schools inquiry, defective masonry construction. If any of us thought that this was a problem only for mainland UK, then headlines only yesterday in the main Irish newspapers would have brought a greater realisation of the likelihood that the systemic nature of these failings also affects the island of Ireland. Both fire safety and structural defects were apparently identified in a significant number of schools recently built in Ireland. Initial reports indicate that the structural defects relate to the lack of adequate wall ties and the fixing of masonry panels back to the structural frame. This would be virtually a repetition of the defects discovered as part of the Edinburgh Schools inquiry in 2016. One technical report suggested an 80% risk of wall collapse and storm winds in a North Dublin school. The Edinburgh inquiry itself was completed. The report I completed in February 2017 when it was published, and it is available on the internet for those of you who wish to refer to it. Just to give a background to the events leading to the inquiry, in January 2016, gable walls collapsed at OXGANGS primary school during a period of high winds. The initial inspections considered it as a one-off event, probably due to lack of embedment of wall ties. Visual inspections of the external walls were carried out by a team of structural engineers on this building, on the other 16 buildings built at the same time under a PFI contract, and showed no signs of stress. They were therefore assumed by the engineers to be safe. However, further intrusive surveys found the same major lack of wall tie embedment issues in all the walls of the OXGANGS school and throughout all of the other 16 schools examined. Significant remedial works were necessary to retrofit wall ties across all of the school buildings. During opening up for this remediation contract, major omissions of restraint and reinforcement elements in masonry panels were discovered across all 17 schools, raising more serious questions about the structural integrity of the buildings. All of these schools were immediately closed, and over a weekend, approximately 8,000 pupils had to be found alternative accommodation in schools around Edinburgh. The widespread remedial work was required, and the independent inquiry was required by the Scottish Government. In May, the City of Edinburgh Council agreed to commission an inquiry and asked me to chair that inquiry. I in turn appointed Stuart McCartney, a structural engineer, and Chris Phillips, a solicitor, to sit on the inquiry panel with myself. The report, as I've said before, was published in February 2017 with 40 recommendations. Some of these have already been implemented by the Scottish Government, and all the public bodies in Scotland have been required to report as to how they are addressing all of the recommendations. The Government have also indicated a series of cross-sectoral reviews and workshops to address how the industry can address this broader problem. Also, as a result of this, I was asked to review the building regulations in terms of how it's enforced and how it's complied with in Scotland. And I've made recommendations which are just being out for consultation, and those changes will be implemented shortly. It's on the next slide. I'll now go into some of the detail of the collapse. On the 29th of January, as I said before, 9 tons of masonry fell onto the pathway below. This photograph shows the layout and orientation of the school. As you'll see from this chart, the top layer shows the direction of the wind and during the storm, and you'll see just around 8 o'clock the wind veered from southwest briefly to south-southwest and then again to west-southwest. At the same time, it gusted up to a speed of 69 miles per hour, still well within the 99 miles per hour which the design code required the wall to be able to resist. So you can see the wind changing direction, and as it does and veers in this direction, it leads to suction on that gable wall, and the gable wall collapses onto the area immediately outside. This diagram shows the pattern of the suction on that wall, and the failed panels on the left-hand side of the gable on the right were subjected to a suction force of up to 1 ton. The outer leaf and inner leaf were, of course, designed to act as one through the inclusion of properly spaced and embedded wall ties. And again, each of these panels, wall panels, was supposed to be tied back to the steel structural frame. In both cases, this failed to happen, and this was basically the reason for the collapse of the wall. Under the codes, there are different factors of safety allowed. Standard factor of safety required is 3, but that can be lowered to 2.5 if there is assurance as to a high level of supervision on site and rigorous material testing specified. Those were actually used by the designers of the building, the reduced safety factor, and under calculations undertaken by 2 firms of independent structural engineers, they showed that if you hadn't, with the lower factor, these buildings would just pass, but if the proper factor had been used, 3, the standard factor had been used, they would actually have failed. This just shows the wind map around Scotland, showing that you get higher winds as you go further north of the British Isles. And this is an interesting diagram which shows that the insurance companies, in looking at the future analysis, are identifying that with climate change, there's likely to be more pronounced storms in the north of England, which means that the wind suction on buildings of this type or pressure can increase, be expected to increase in the future, leading to more claims against the insurance industry or to more collapses of buildings. The specification for the school in Edinburgh, it was pretty standard. It was a cavity wall with an internal block leaf of 140 mil, 120 cavity with a 70 mil insulation clipped to the inner leaf, and an outer face of brickwork or rendered block work. The wall ties specified were a heavy duty 250 millimeter length Vista type wall ties, and each been required to have a minimum embedment of 50 mil, although if you read the manufacturer's instructions, they recommend a minimum embedment of 65. Bed joint reinforcement was used, was specified widely throughout the school buildings because of the size of panels involved and was required to give the structural stability needed. On the right hand side, the head restraints specified with a type with a sliding anchor and tying the wall in 2 places on the outside leaf in 2 places, and tying back to the inner leaf, all tied back to the structural frame. This diagram actually shows something we found, that there was a differentiation between the architect specification, which showed that those head restraints should be fitted at 900 centres, whereas the engineering drawing showed 450. In fact, we find that they weren't fitted in most cases at all. Failure to fit the head restraints will actually lead to a reduction in the strength of the wall of up to 45%. The other issue which came to the fore was that we noticed that we were advised that the inner leaf of the wall was built first completely, and then the outer leaf was brought up afterwards. This is used to create a dry environment for trades to move in earlier than they would otherwise be able to do so. However, this was in conflict with the recommendations and the specifications, which required that no height be, that the 2 leaves be brought up together and that the leveling of courses. This was in fact pointed out by architects to the contractor for whom they were working for, and was largely ignored. There are many problems associated with building the inner leaf first, particularly in that you're relying on the grip and suction of the mortar to hold ties placed in place if you don't have an outer leaf on which to also rest the tie. As a result, bricklayers push the ties further into the inner leaf, leaving insufficient depth in the ties to give the adequate embedment in the outer leaf. Alternatively, they may push the ties into the wet joints after building the brickwork. This simply causes a void and doesn't give the traction required on the wall ties. Also, the inner leaf is generally built by people with less skills, as is block work rather than the brickwork on the outside. And if it's built off the plumb, perhaps to follow the line of stanchions, then the outer leaf being built to plumb means that there's variation in the cavity width. This photograph shows one of the head restraints built into the cavity of the wall and being attached to a steel beam. But as you see in the close-up here, the wall ties, which are supposed to be on the sliding anchor, connecting the anchor to the inner and outer walls, have not been built in properly and are just hanging from the tie, so they're not fulfilling their purpose at all. This drawing shows that particularly where they find sloping beams, as in the case of the gym you see here on the left of the picture, that in virtually all cases those ties were left out, as it was more difficult, found to be more difficult for the bricklayers to fit the head restraints to a sloping as opposed to a horizontal beam. Again, an example of sloping beams where you find that the no restraints were fitted, as you'll see in the notes. These are notes from the inspections undertaken prior to the retrofit. And again, significant areas of wind posts were required to be installed because of the lack of head restraints and also the lack of bed joint reinforcement that was found throughout these walls. This shows the collapse of that main wall onto the pathway below, which leads to the door into which the children would generally enter. And again, it's important to point out that this was one of 17 schools, but the schools were built by 6 different contractors, each using design and build as part of a total project. So it wasn't one rogue contractor here. It was a range of 6 different contractors who all succeeded in achieving the same defects across all 17 schools. This slide shows the pictures at 8 o'clock on the morning of collapse on the top, and what would be normally happening at 9 o'clock on that same morning. So one can imagine the consequences if it had just happened a little bit later. There would have definitely been fatalities. This picture shows one of the bays in that wall after the collapse of the outer face. And you may be able to see that the inner part of the bay, to allow the diagonal bracing to pass, has been recessed to 100mm blocks. However, the wall ties used were still the 250mm, which actually made it impossible for the ties to actually achieve anything like the required embedment in the outer relief. However, in the adjacent bays, you can see that the ties were again over. The embedment was too much in the inner leaf, leaving little short areas standing out to connect onto the outer leaf when it was being built up later, and also areas where no ties were obvious at all. These are internal pictures of the walls of that school, and you can see the end of the tie just touching the inside or outer face in both these cases. And here's a different school in the same block of 17 schools, again using a slightly different wall tie, but again failing to reach the outer leaf or the inner leaf. And again, the same issue in different schools in the group. Virtually no effective embedment of wall ties into the outer leaf. I'm not going to very, very quickly go back to Vitruvius, who I mentioned at the start in relation to durability, in which he's comparing the work of Romans and his own workmen and Greeks. And the first one, he says, our workmen, in their hurry to finish, devote themselves only to the facing of the walls, setting them upright, but filling the space between with a lot of broken stones and mortar thrown in anyhow. I'm not sure. This is 100 years BC. He contrasts that with the Greek workmen who he had seen. They leave a cavity between the 2 walls and, skipping a little bit along, bind them to the fronts by means of iron clamps and lead. The beds and bills, all settled equally and bonded at the joints, will not let the work bulge out, nor allow the fall of the face walls, which have been tightly fastened together. One who, in accordance with these notes, will take pains in selecting his method of construction may count upon having something that will last. It would appear that large parts of our construction industry in the 21st century seem to have forgotten this basic 1st century BC lesson. You can see here the retrofitted wind posts, both horizontal wind posts and vertical wind posts, and restraint plates tying the internal walls to the beams, intermediate beams, and the top beams to provide the required structural integrity. And you can see the impact that had on the building. I'm not going to go through this diagram in detail, other than to say that on the left-hand side you see just 6 of the 17 schools, and this records the amount of areas which had no bed joint reinforcement, which lacked head restraints, and which had inadequate embedment of wall ties or missing wall ties. And you'll see the numbers are all 60, 70, 80, 100%. This demonstrates major failing of quality across all of those aspects, across all of the schools. As I mentioned before, the defects found in Edinburgh, while originally called in to look at, were to do with structural integrity. We found across the 17 schools there were 300 examples of breaches of fire compartmentation. As shown here in these examples on the left, a partition that should have been carried up to the roof, just carried up to the soft flat beam. And on the right-hand side, a major hole through a firewall where the surface passed through, totally on fire stopped, and compromising the integrity of the building. So the issue really is about the quality assurance that we get from the industry. As I said before, we had 6 different contractors building 17 schools, each with an approved quality assurance system. The subcontractors used had similarly approved quality assurance systems. The firms of architects and the firm of construction engineers used in all projects had QA systems, as had the national firms who acted as independent testers. And additional to that, building control inspections were carried out. Despite all of these quality assurance systems, which were paper-based, the following 5 fundamental defects occurred at a consistently high level throughout all of the buildings: cavity width, lack of embedment, missing wall ties, missing head restraints, missing bed joint reinforcement, defective fire stopping, and missing fire stopping throughout the schools. So again, who was looking after the quality despite all of these quality assurance processes and systems? The inquiry sought information from all Scottish local authorities, in addition to Edinburgh, and found that the same defects had been present in many schools from across all parts of Scotland. In the previous 4 years, there had been at least 5 collapses of external brick panels in recently built Scottish schools, the causes being virtually identical to that found in the incident in Edinburgh. There was no effective coordination of these issues as an industry-wide problem. In February 2017, I concluded that similar defects were likely to be spread throughout the industry and recommended proactive risk-assessed investigations should be undertaken, and hundreds of buildings have subsequently been identified with those defects. As a result of this inquiry, also found that clients should not rely solely on quality assurance processes of contractors and must provide for their own independent expert scrutiny. These photographs show 4 different examples of schools built outside Edinburgh, showing exactly the same failures in relation to no embedment of wall ties, deformation of wall ties, and a total absence of wall ties, one wall in a gymnasium. And this photograph shows one of those collapses I referred to, which happened in 2009, again, a part of a PFI design and build contract. It is the same pattern of collapse on a slightly smaller scale than that in OXGANGS school, but it also occurred in a period of high winds. And you can see the pattern is virtually identical in both projects. The second inquiry is in relation to major defects, including those in the Edinburgh schools, but at a much wider range of defects that were found in a large event and leisure centre complex in Dumfries, in which I was also asked to chair the inquiry, and this reported in April 2018. Again, this report is available on the internet. These headlines are from local press, which found the building, the range of defects to be absolutely amazing. Each of those red marks identifies a different defect that was found across this building. The defects were found in every aspect of the construction, not simply in the walls and in the fire stopping. I'm now going to take you on a very quick trip through some of the photographs showing the defective work in different areas of that building. This is street elevation showing the effervescence due to a constantly saturated wall. This photograph on the left shows the infrared of that on the right, and the areas of white show where the insulation within the wall has been left out so that you're getting no insulation and energy seeping from the building. All the photographs showing exactly the same along all the columns, the cold points at these points. Again, totally missing insulation in the building facade. This is one of the smoke tests, which shows the air tightness was just non-existent. Smoke came pouring out from the building exterior wall, and also on the right-hand side, from one fire compartment to another, the smoke poured through, demonstrating that the fire stopping was totally ineffective. This is inside one of the cavities, showing that the insulation just stopped at a certain point, and again a cold bridge across this steel column. Again, insulation missing within the wall, and a major gap here between the insulation and the roof and the wall, leading to again an area where the warm air just escapes from the building. This is the edge of the building, as you can see inside, the insulation just stopping short. This just shows the inability to achieve a factor of about 10, the specified energy effectiveness of the fabric. These photographs show fire stopping, which is of primary interest largely because of the Grenville incident. And you can see major holes in firewalls. This is an R-fire resisting wall on the left with a huge gap that the service has just passed through and hasn't been fire stopped. And this was found to be throughout the building, throughout the floors of the building, at all the voids, wherever the services passed through, again, where beams passed through. Again, no smoke seals, no attempt to seal. And yet this building was open for 3 years before it was recognised these major safety compromises existed within the building, and the building had large audiences of 1,000 at a time. This particular example on the right hand here, you can see a firewall where the one block was just left sitting on the wall wasn't even completed. And this had passed inspection by the quality assurance processes provided to the client by all of these contractors. Internally in the building, virtually every piece of metal and structural steelwork as well, which is supposed to be protected, was found to be corroded, largely in these instances by using the wrong grade of steel in an environment which is chlorine in it. So this is only after 6 years of use in the building. These horrific photographs of the interior as a result of leaking pools onto the structure of the building. This was supposed to be a temporary solution, but remained a permanent solution as to how the contractor dealt with a leak from an upstairs spa area. Instead of fixing the leak, he put in a funnel underneath it and ran it into the drain systems. The leak just continues. But as you see, even the funnel wasn't effectively fitted by the damage completely around it. Corroded being just under the tiles and the surround to the swimming pool. All of the rebar within the walls of the swimming pool was corroded with this black corrosion. And you can see the depleted section as a result of that corrosion, greatly reducing the strength of the wall, and these walls all leaked like sieves. The effect of the leaks to other parts of the building, damaging the plant and the wiring, electrical and mechanical services. Again, an interesting detail. Here's this main switchgear for the building being protected by a tarpaulin, which is dripping the water into that bucket that you see on the right-hand side. Because otherwise the risks were immense. The risks were still immense, but this is ridiculous. Corrosion at the base of a column in the plant room. And you just see more and more of the same here. I'll move on to the next section. This is, sorry, just on that last one. These are the underground sections of the columns which weren't properly protected and again corroded. This was only discovered when it was dug away around the concrete around the columns. This was revealed to show this corrosion. Drainage. The drainage in the roof was totally inadequate. Badly laid out, the falls were in the wrong direction. And in the underground drainage, you could find that the drainage immediately under the floor was packed up on bits of stone or actually held in place by wire and taped joints. Now, this building was built by an international large contractor still carrying out major work across the UK. The walls, to go back to the same issue as was raised initially in the Edinburgh schools and was just raised its head in Dublin. This before and after photographs are normally shown, are normally shown the other way around. So the after is when we came to site where the building actually had to be knocked down to be rebuilt. Again, you can see here no evidence of wall ties within these sections of the wall structure. Again, exactly the same as in Edinburgh, the wall ties just touching the walls, not being embedded at all. An area where there's no inner relief. And in this situation, a scaffolding tube from the original construction was left on the wall, and they just stopped the insulation and the timber on either side of it and didn't bother removing it and doing it properly. On the right-hand side, the blockwork again was not tied by head restraints to these beams. And again, just to show the state of the building after 6 years, this is the roof. You can see the misalignment of elements, corrosion of the plant fittings on the roof, the air handling units, the exterior cladding, the brickwork, sills, other fittings. Right. And again, in the pool, there were 3 swimming pools in this building. The tiles were failing left, right, and centre throughout the building. All had to be removed. The walls had to be reconstructed and tidying replaced as part of an ongoing project to fit it. What did the client feel they were getting in this building? Well, they felt they had a major national contractor. The contractor and subcontractors had submitted tender documents which provided massive amounts of quality assurance processes and certificates identifying them as a quality assured organisation. They thought they were getting regular inspections of work by members of the design team who were, of course, working with the contractor. While these were specified in the scope of the services set by the contractor and in collateral warranties provided to the council, they did not happen with the frequency specified. Design and build had been chosen by the council as more likely to achieve tight cost and time objectives. Again, quality as an original driver of the project was quite forgotten. Council officers relied on being able to seek reimbursement through the contract if things went wrong. I don't think they envisaged that they might have to close the building for what would be a period of 5 years by the time it reopens. The compromises on the design and build contract that contributed to quality failures in Edinburgh and Dumfries was failure to fully integrate and coordinate the design before construction started. There's failure to ensure that the design would actually comply with building regulations. There's virtually no independent scrutiny of construction on behalf of the client by properly resourced clerk of works and resident architects or engineers. The design team members appointed by the contractor had no authority to instruct them to redo non-compliant work, and snagging by that team was discouraged or even excluded. There was failure to have professional sign-off of changes to the design or substitution which happened during the course of the project by the main and subcontractors prior to the implementation on site. And most importantly, in my mind, there was no direct relationship between the client and the design team with regard to assurances that the quality of construction being carried out was in accordance with the design they produced. Design teams, as I said before, are increasingly being marginalised to pre-construction office-based activities. The golden thread between the original design and implementation of that design on site has become severed. Professional knowledge is increasingly absent from decision-making on site. There's little point in having approved sets of building drawings if there's no assurance that what is actually designed is built. Designers are frequently unable to ensure that their underlying design intent is being delivered, particularly in relation to structure. And the number of visits by building control inspectors are totally inadequate to provide the sort of quality assurance that clients actually require. Design teams, unfortunately, are cutting back on the production of documentation, with more design being delegated to subcontractors. Site visits are reduced, leading to a gradual de-skilling of our professions, particularly among younger members who will not have the same familiarity with the practicalities of building on site and the use of materials. There's a significant reduction in the use of clerk of works, who are less and less obvious and much more difficult now to find. Contractors are increasingly determining the level of services provided by the design team, including their level of inspections on site. And design team members are often contractually prevented from reporting directly to the client and potentially being overruled by site managers who have inevitably conflicts of interest. The other problem with the industry is that architects, engineers don't necessarily fully coordinate their drawings. And if one thinks about the bricklayer working on site, he can't have 3 or 4 drawings looking at the same time. And evidence shows that they frequently work off elevations only, so they're probably not aware quite often of head restraints, other restraints, their joint reinforcement requirements. We need to make it easier for our contractors on site. The inquiries had a wide range of recommendations, and these required actions right down from government all the way down to the individual workers, going through the professions, design teams, contractors, subcontractors, and manufacturers. And many of these recommendations, I say, are currently being implemented. I've already, I think, covered that slide, that there's a series of ministerial summits on, including the client bodies who are seeking a planned program of initiatives aimed at improving quality. The contractor issues, a culture that is often focused on cost and time to the detriment of quality. Quite often, the main contractors and managerial staff have less knowledge of actual building trades, more coming from a management background. Insufficient supervisory staff on site, the lack of training of young apprenticeships in the building trades, more trades being employed as self-contractors moving quickly from project to project, the squeezing of subcontractors for lower prices, which results in lower quality, the widespread evidence that paper-based quality assurance systems quite often be a box-ticking exercise in offices rather than a site observation-based quality inspection. Design teams are longer snagging, and the conflict of interest in removing defective work. This is a diagram that I use quite often when speaking to groups. And really what I'm saying is that by disinvesting in that initial small yellow circle, which is the design team input and the quality processes to protect the client's interests, can lead to larger and larger circles. And the cost in use to a client can be 50 to 200 times the capital cost of the building, which is reflected in the blue circle, the cost of the building. Quite often, design and build contractors are only interested in reducing the yellow and blue circles, whereas clients should be totally interested in the cost of maintaining their buildings, which is the 5, and the 50 to 200, which is the operational cost of the building over its life. And yet, all of the cuts made in that little yellow dot, and by making it subservient to the blue dot, is likely to lead to much larger costs in the life cycle of a building to clients and to their detriment. So, concluding thoughts. There's a need for a changing culture within our industry to improve the focus on quality, and I think that Grenville has really brought that to the fore. The original role of the architect and design team in protecting the quality of construction for the client is no longer the norm. This role needs to be restored, or an equivalent role. There needs to be an appreciation of the value to society of buildings over the long term, and an understanding of the potential tragic consequences, such as Grenville, of substandard construction. A focus of greater efficiency in delivering the required quality rather than on cutting quality to achieve reduced cost and the misuse of value engineering processes. A focus on developing a workforce which has the skills managerially and operationally at a trade level to meet the needs of a changing industry. We need to re-professionalize our industry. Time and cost, while important, are short-term objectives. Excellent design and construction quality endures and goes on giving when time and cost are long forgotten. This is the unacceptable and unrepeatable cost of cutting quality in construction. We cannot allow this to happen again. Alternatively, when we look at the examples I gave initially of the university buildings built in the last few centuries, the investment in the quality of design and construction endures and goes on giving. Thank you.
John, I'm not quite sure I've ever heard anyone speak so clearly into and diagnose such a drastic problem in our industry. You've given such clarity on the issues it was a horror show at times watching those photographs, and that already some people have written in and says, can they get a copy of that slide deck? There is a recording made of today's webinar, so you'll be able to access that following today's session. I'm keen to open it up to questions because no doubt there will be quite a few that have come through. So we're quite keen to hear from you. So if you haven't had a chance just yet, if you want to write your questions in the Q&A box on the right-hand side, that would be great. Okay, question coming in here. And it says, from a quality perspective, most of the defects are due to poor workmanship, execution, or poor design, or both, where people need to concentrate more. You know, you talked about clerk of works, John. You know, I had a conversation with the chief executive of a main contractor, and he referred back to his early days and how on a job he was grateful for a clerk of works being on that job, because he knew that at the end of each day, when he went home, end of each week, that he could rely on having done a good job.
Yeah, and I think that's absolutely true. And I was working in the industry at that time myself, and as an architect, young architect particularly, I learned probably more from working with experienced, high quality clerk of works than I did at university from a technical perspective. Mm-hmm. That system has greatly been reduced now. There are no longer courses for clerk of works in the way that it used to be. It's very difficult to find experienced clerk of works, and people take on that job. But that's because a lot of clients didn't want to retain clerk of works because they felt they were retaining risk by putting clerk of works on site who might give instructions and directions and therefore be seen to have contributed to bad workmanship. So this concept of transferring all risk to contractors is totally misplaced. What you don't want to do is transfer risk and be able to sue people. You want to be able to build the right building in the first place. And the clerk of works with the eyes and the ears of the design team. The fact that the design team now works for a contractor in many instances has changed that whole relationship. They're not there to protect the client anymore. They're there to service the contractor. And since they will rely on contractors for future work, there's always a resistance there to report the client defects at design team members on site. So there are defects in design still. I think there's a remoteness now between design and site, and a lot more work is being transferred down the system to subcontractors. But the key issue is the quality of workmanship on site and the supervisory skills and staff and knowledge of main contractors in that, and the incentives usually on a cost and time basis rather than the incentives on a quality basis.
Okay.
Bricklayers get paid by the number of bricks they lay. It has nothing to do with the amount of head restraints or lateral restraints or bed joint reinforcement, all of which slow up the work and reduce the earning power. Yeah. So you can see why in many cases in the Edinburgh schools project we find the fittings I described sitting left on the beams rather than actually fitted, because that would have slowed up the bricklayers and reduced their daily earnings. Mm-hmm. We have to do something about a system which incentivizes poor quality behaviours.
Okay, thank you for that. Philip Marsh has asked a question around communication, and he's asking about during the project, were these issues not at least being talked about? Did your review and OXGANGS look at some of the behaviours that were going on during the projects between the design team and the contractor?
Yes, and I would pass over some of these things very quickly, but you'll see that I refer to facts where the architects in some instances went on site, reported defects and were ignored because the contractor was taking the lead and deciding what he would and wouldn't do. And we were advised in certain instances that the architects had no authority to overrule contractors' views on this.
Okay. Question coming in around punishment for those contractors. Has there been any outcome in terms of the client taking those contractors to court?
Not taking them to court, but in the Edinburgh case, the client, remember, was a PFI organisation. Okay. So the Edinburgh Council didn't own the schools. Yep. It was owned by the PFI, and the contractors had to pay the cost, contribute with the cost of the full retrofitting. So Edinburgh Council didn't have to pay for it, but they were also seeking damages in relation to the cost of relocating 8,000 pupils and associated costs of the inquiry, etc., which arose from that. So they are seeking that. In the Dumfries case, there was a settlement in court for £10 million. However, when we started to look at the defects, it was found that the actual cost of fixing the project would be over £20 million. So the council will not be able to get back its full cost, yet it was relying on the contract form rather than by putting proper scrutiny on the job as a way of protecting its interests. And that clearly didn't serve to do so. And unfortunately, much legal advice is telling clients to push more and more risk onto contractors, whereas actually clients need to get involved in projects and have their own independent expertise working for them to ensure they're getting the quality they're looking for.
Okay, thank you. Michael Woods has said here, being an experienced civil engineer, I've been able to protect my clients by identifying these types of defects. How do we reinforce the message to clients that they need that site monitoring during the construction phase, especially when there's such a focus maybe on an annual budget and getting money spent?
Well, as a result of my inquiry, the Scottish Government at the most senior level wrote to all local authorities in Scotland and instructed them to use independent site inspections on all of their projects. So that has already been a very positive outcome of this inquiry. Now, because it was Scottish based, that's only happening in Scotland, but it needs to happen elsewhere in the different jurisdictions.
As you referred to OXGANGS, you said it was only by a matter of timing and luck that no one was injured, and Dumfries as well. Thankfully, no one has been injured by that. But in terms of the public confidence and trust, did your reviews consult with the wider, not even the schools or the leisure centre users, but with the wider public to get a sense of how they're lacking trust really in the industry to be able to deliver?
No, that would have been outside the remit of my inquiry to go outside, but we did consult the users, with the parents of children who attended the school, with the school teachers, etc. And there was a significant questioning as to how could modern buildings, which are only several years old, be in this condition when many of the buildings that they've been educated in had been there for hundreds of years beforehand.
Yeah. Do you have any sense with the likes of OXGANGS how much it's actually cost to put it right, or have the buildings been reopened? Or
all the buildings have been reopened, and in fact the remediation project was done quite quickly. And to be fair to the contractor who did the repair work had bought over the original firm, so it wasn't the same people. So there actually was a positive response by the contractor, and I have to applaud them for that. In terms of how quickly they faced up the situation and addressed it. And as you can see from the robust nature of the repair work that was undertaken, I think these buildings are probably pretty safe now. In fact, if there was a nuclear explosion here in the Great Britain, I think you'd be safe enough in one of those schools.
Okay, they've gone over and above.
They've been well fixed, yeah.
Okay. You mentioned about the lack poor communication between the different parts of the project team. Building information modelling and digital technology has been used on projects to help bring together the project team, even at an earlier stage, and to try and iron out some of those design issues, clashes, etc. But it's also changing the behaviours of the industry. I wonder, is there any sense from your perspective that the likes of building information modelling, while not a panacea, can bring some of that focus?
It should be more helpful. As I said, one of the key issues, and it was apparent to us because we had to look through about 6 different sets of documentation to establish what was required in the specification of those walls, whether there was bed joint reinforcement, where the lateral fixtures were, etc. The whole issue. And if you're a clerk of works jumping out of a van and being pointed at a wall and be given an elevation which has no information on it, that you're going to get a situation like this happening. The problem is there was no supervision, no coordination of animal information. It wasn't being brought together in a format. And if you think particularly in Scotland on a cold winter's day with the rain pouring down and mud in your boots, are you going to be able to hold 4 or 5 different pieces of information, including specifications? You're not. So unless somebody is leading that from the top, and the information is provided in an integrated way. So one of my recommendations on Edinburgh was that the architectural information and specification information should all be put together on issues like wall construction on a single piece of documentation which is available and accessible to bricklayers working on site conditions. And of course technology can significantly help that.
Just thinking of another form of technology, the likes of off-site construction, has been again mooted as a way in which we can improve quality in our buildings, and even bridges can be brought to site in a flat pack model and built. What are your thoughts on offsite?
Well, I don't want to get into detail of it because I don't know too much about it, but as you know, 40 schools in Dublin are being looked at today. They were largely off-site prefabricated solutions, but the issue is how these elements are put together when they get on site. Mm-hmm. And one still has to have the conductor of the orchestra. You may have the individual pieces, but it's how they're put together and how they're held together and how they act in totality as a structure. Somebody has to give that assurance. And that comes down to observation and knowledge of the people on the site.
Okay. John, I think we're going to have to stop there. Lots of questions coming in. I think that's the most we've ever had. And it was great to see over 150 people joining us for the majority of the webinar. Our thanks to John for his enlightening presentation to us, and also to Richard Fitzpatrick, the chair of Lean Construction Ireland, for co-hosting this webinar with us today. ICE runs webinars most Thursdays at this time, and it's great that so many from around the world have joined in with the conversation today. So keep an eye on the ICE events webpage for upcoming webinars. As you close out of today's webinar, there will be a survey which will pop up. Can you please complete that? It'd be great to get your feedback on today's session, and we can hopefully use that feedback to make future sessions even better. Thanks very much for your time, and
Richard,
have a good day. Yes, Richard?
Rich, I was just going to say thank John as well for those insightful views into those projects, and certainly a lot of lessons learned there. And similarly, the ICE Construction Ireland has monthly webinars as well around lean thinking, lean practices. So we certainly invite those who've tuned in this afternoon to look at Lean Construction Ireland website to see what webinars are available there to try and gain some knowledge on how we can address the issue of quality and lean practices on construction. So thanks, Richard, for accommodating us and co-hosting it this afternoon as well.
That's great. Thanks, Richard, for that, and have a good day, everyone.